So in this section 11.2, we're going to find the equation of a parabola. And let's say they automatically tell you what A is. So in this case, I'm going to say that A is going to be 2. And they tell you the vertex point. So the vertex point is going to be parentheses negative 2, 1. So if you had a graph, okay, this is X, this is Y. Because A is positive, this would have to be the lowest point. The lowest point. So if I went to negative 2 and then I went up 1, the parabola's got to be here. The vertex has got to be right here. So this is where my vertex is, my vertex point. So I do know the general form is A times X plus H squared plus K. Or it could be minus or minus. But this tells me. So I see that I have a 1. That's going to be my K because that's my vertex. So I know that it's plus 1. Okay. And they gave me A, which is 2, and X. This is the only part that can be tricky. But this is the negative 2, which is going to be my H. And remember, it's always the opposite. So if you think about it, it should be plus 2. Because then X will have to be negative 2 to make it work. So we can check that on our calculator by going to it and checking it. So if I went to Y equals and cleared out the equations, okay, I put in 2 and then parentheses and then it's X. It's going to be plus 2 to the power of 2 and then it's plus 1. Okay, so now when I hit graph, the lowest point is exactly where I thought it would be. It'd be negative 2 up 1. So I see that. And now I could just figure out where the other points of A's are. So I can use my table if I like. So I'll go to the table and pick some nice numbers. So I can see that at negative 2 I get the 1. And so I have negative 3, 3. So I go to negative 3. So 1, 2, 3, 3, and up 3. So I get a point here, and then I'll get the opposite because this is a parabola, and it typically, whatever point's here reflects over here, so that's 3. And so it looks something like this. Okay, with arrows on both ends. Okay, so I look at the graph, that's kind of what it looks like. Okay, and the second table gives that. So we have reflections, you have 3, 3, 0 gives you 9, so negative 4 should give you 9 as well, and it does, see? So it's reflecting, so on the curve it reflects across. And so then we'll learn later about there's an actual dividing line here. It's really not there, but it has a name. It's a dotted line, and we call that the Axes Symmetry. Okay, because if I took this curve and folded it along this line, this curve would match on the other side. They reflect across each other. So they call that the Axes of Symmetry. Okay, and so that's that setup. So the next step is to change this vertex form into standard form. Okay, so we're going to do standard form with this one. So we have y equal to 2 times x plus 2 squared plus 1. And so the first thing we have to take care of is the x squared. So this happens first. So we have to do the exponent first. And so that really is what's twice inside here. So I'm going to write it twice. Okay, and then we're going to multiply everything. So we're going to take, I'll do as a bracket, but we're going to take the 2x times the x, and then we're going to do the x times the 2. We're going to do the 2 times the x, and then the 2 times the 2. And yeah, plus 1 at the end. So now we go ahead and multiply. So x times x is x squared. We have plus 2. Oops. We have, Harry, go lay down. Oh. Okay. And we have 2x and 2x, and then 2 times 2 is 4. Okay. So now we can combine like terms here, can't we? So the 2x and the 2x are like terms, so we can combine them. So that gives me 4x plus 4. Okay, now I can't combine anything else in here, so I've got to do the next step, which is to multiply the 2 by everything inside. So 2 times the 2x squared is 2x squared. 2 times 4x is 8x. 2 times the 4 is 8 plus the 1. And so we end up with 2x squared plus 8x, and then we can combine the 8 and the 1 to give us 9. And so here is standard form. Okay? And that's how you do these kinds of problems.